Hello, my dearest programmers. Welcome back to Jungle Code. My name is Can Rau, and in today's episode, I'd like to walk you through the first actual microservice for the Jamstack contact form API. So let's jump right in. All right, so now that the infrastructure has been deployed, let's check out the actual contact form, shall we? First, let's check out the package.json. In here, we have the same convenience scripts. And by the way, you can use those scripts here to not only set the yarn and node environment in this. It's missing. But you can, for example, I believe it's called AWS profile, which I'm going to do once I manage my AWS profiles for different accounts. Then I can define them in here as well. Like, for example, AWS profile, business name, or how you call it, or organization, and can you have even like a different one for development and for production, and for every Pulumi project you can have a different AWS account. Account in this case can be in one organization, but having different sub-accounts which they recommend for better differentiation between projects. Essentially, it seems there are businesses or like people using an account per microservice. For example, they have one account only for the contact service, one account for newsletter service, one account for whatever else. So there's different options you can choose from, and those helper scripts here, those convenience scripts, are, in my opinion, a good way to set the AWS account accordingly. Okay, so Pulumi AWS contact is and we have here some test scripts and for coverage, and I will explain those later. Stack import and export. Those can be helpful if you run into problems while deploying and either have to cancel the deployment because it just takes forever or it fails for whatever reason. Then you can export your Pulumi stack to a file. In this case, I just named it boldly Pulumi export in the same directory. And then in the exported stack file, you can, usually what I have had to do so far was delete resources Pulumi thought it already deployed but couldn't for whatever reason, like an error or you canceled it. So it has problems later to update or destroy or delete the project. So you can manually go in there, figure out what might cause the problem, delete it manually from the stack file, then import the stack file once you fixed it manually. The file can then be deleted because that's just like the exported stuff. It's not the actual storage. So you can delete this file, at least exclude it from your repository, I would say, for example, like so. Yeah, and then be good to go and update your stack, your project stack, or delete it successfully, hopefully, if you've done a good, correct job. Tester coverage, dependencies, some settings for AVA, NYC, prettier. Yeah, basic NPM stuff. So the same here. We have the Pulumi project file, but no stack so far. So let's change directory into Pulumi AWS contact and create a stack in it, call it contact dev. Secret confirmation, and created the stack successfully. And I have to check, I'm not exactly sure. I think we don't have to set, we have to set at least the Pulumi config set AWS region, which is now here. And we can see in the code later if we missed any other configuration, but I believe everything should come from the infrastructure project. So let's go on the index.ts file, which is the main Pulumi project. So we import the contact handler, which I'll show you later from here, from handlers contact.ts. And I made a contact handler factory, which I'll explain later why. We get the local config, that's the configuration from here. I just set it up as alternative. So we get the origin domain and the contact email from the infrastructure project, but we can override it per the local project configuration if we want to, for whatever reason. For example, we have multiple microservices and one of them doesn't use the normal origin domain or contact email, or you want to change it for one specific stack, then you can just override it, but you don't have to. So the local config like this, we set up just a couple of seconds ago, is good to go like this, just with a AWS region defined. Let's go back to index and back to the top. So the stack we get from Pulumi, the stack, which in this case is the stack name is this here below in the terminal, contact.dev. That's the stack name. That's what we get. The environment, in this case, will be the second part if we split it on the dot. So this is the environment. And you can, of course, have your own naming conventions or how you define the environment. If you need or want an environment, that's up to you. So in this case, I adjust the normal string split on dot, on period, and I get the second array item, the index of 1, to get the environment. Then, this is where the referencing part happens. We get the infrastructure project using pulumi.StackReference and providing which stack we want to reference. And this is the reason why we store the Pulumi configuration, or like the Pulumi backend, why we use it in this directory, where we set it up like we did earlier, to easily reference exactly what we want. Otherwise, if we wouldn't prepend it with a project name, then we couldn't specify exactly which project we want, because they would all be called dev, for example. Yeah, and if we would use the default backend, which is Pulumi, if you remember, I'll show you Pulumi login local. This would be the default login, or the default local backend, where Pulumi puts the .pulumi directory in the home directory. Then, even if we then prefix each project with its project name, we would have a lot going on in there. For this reason, I feel like it's cleaner to have a Pulumi backend per business requirement, let's say. Okay, so we get the Pulumi stack reference using the stack name and environment, and then we require the output values, API domain, contact email, and origin domain. And I will, as a reminder, show you that we here in the index.ts export everything from config. So in config, we have those things: origin domain, API domain, mail domain, contact email, etc. So this is the stuff we require here. And there's different ways of getting values from another project. I can show you here you can have get output value, or require output value. The difference being, when you get output value, then it won't fail if it doesn't exist. But in this case, or in the case of those three here, we want it to fail because there is no override, there's no backup, there's no alternative. We need to get them. So if they are not available for whatever reason, our program exits early and tells us, hey, there's some configuration missing. And the difference between require output and require output value is that with the require output, we get an Pulumi output. With require value, we get the value essentially once it has been resolved. Okay, next, the API domain. Yeah, those I'm not exactly sure, and it is kind of contrary to what I just said. The domain, we wrap it again in the Pulumi output, because otherwise, for example, to show you what I'm talking about, I couldn't do essentially what my first intention, or my first logical thing was, do this. The problem is, Pulumi understands that those have a value of Pulumi output because it's only resolved at runtime. But this here is not a Pulumi issue, but you can't string interpolate API domain, which is not stringifiable, I believe. So that's not possible. You can't put it like in this kind of static way. So you have to wrap it in an output to then be able to use Pulumi's promise-like helpers, in this case apply. Let's go back one more. And then we can transform the output string, in this case I named it S, which will be the domain, like the actual value, prepended contact dot. So then we get in the end contact.api.domain.com, just for clarification. And here we define the tags. We could, of course, like we did in the infra repository, put also those configuration things in a separate config file. It doesn't really matter, it's just like personal preference. Okay, let's go on. Let's close the search. Then we defined our values. Now we create the DNS zone of the contact API domain, which will be this one. It gets its own Route 53 zone using the domain and the defined tags. Then, because we created this infrastructure project beforehand, we have this Route 53 zone of the base API domain, which is just this part. And we got the, where is it? Zone ID from the infra require output. So we require the output from infra, DNS zone, apply it to transform it essentially, because we need the zone ID. and we take out the zone ID. So Pulumi then internally, when it evaluates those at runtime, it then evaluates this string basically to the actual zone ID. It resolves it to the zone ID and puts it in here. And here we create the NameServer records, the DNS records, on the base API. So we don't have to manually edit or change anything. And here the DNS record of type NS, NameServer, for the domain on the zone ID from the infrastructure base API with the records of the newly created DNS zone for the contact domain. And from this we can get the name servers, apply them, and yeah, basically just get the strings out, because this one accepts a string, I believe a string, array of strings, and so on. So on to the next one. And you don't have to put the output of a resource, in this case the Route 53 record, in a variable. We don't need it later for nothing. We don't want to export it. We don't need it in another resource. So we can just run this as is without stuffing it in a variable. So next, we have to, like what we do want, like the comment says, provision an SSL certificate to enable SSL for the contact API domain. And to do so, we need first, because Amazon Certificate Manager, ACM, only allows certificates to be created in the US East 1 region. And just to make sure, because your project or stack you can deploy to whatever region, even though right now it's the same region defined here, US East 1, we could change this at any time, but want to make sure that this resource will always be deployed to the US East 1 region. So we can say new AWS provider. This is just an internal name, which every Pulumi resource has to have. Then give it a region, US East 1. And in the AWS.acm certificate resource, we can define our custom provider in this case. So it overrides the provider from the Pulumi config essentially. So the SSL certificate for the domain name, for the domain we defined here, validation method DNS, which we then later do as well, and adding the tags, the project tags. So then the necessary DNS records for the certificate to validate ownership. So we don't have to do anything. Route 53 DNS record, give it a name, the zone ID of the contact API Route 53 zone from the SSL cert. So those are basically coming from the Pulumi documentation, just copy paste. You can get the DNS settings, DNS records for the certificate to approve it. You can get it from the SSL cert resource, which is this one. So once Pulumi deployed this one, it stuffs all the information it has in this variable, or it resolves then, and then we can pick out the name, resource record name, and resource record type from the first array item, and then the record itself as well. And I basically just copy pasted this. And this get SSL certificate validation confirmation to use it depends on. So this is not really a resource itself in that sense. It is a way for Pulumi to resolve once this has been validated. Because when Pulumi deploys this resource, then the certificate will be pending. But this has already resolved. And this one goes kind of like back and checks and like pings or whatever exactly it's doing to figure out when it has actually been validated, because it can this can take time, the validation of the DNS records for the certificate manager. And because we have to know later when the certificate has been validated, that's why we use this special validation resource and put it in the SSL validation issued. So once it's issued, this will resolve. And later we will see where we have to use it. So then Pulumi can plan the dependencies correctly. Here we start our Lambda role, because you could of course just use the default Lambda rules, but it's always nice to narrow it down as much as possible to only allow what you really use. And I added this comment here based on, so that's where I actually got the policy stuff from, because it was kind of confusing in the beginning, because I'm still pretty new to AWS myself, how they actually worked all the pieces of the roles and policies. So this is the role. Then we define a policy document. So this is just basically a normal JavaScript object, as you can see. We say it, or we say tell TypeScript Pulumi that this is of type policy document from the IAM AWS module, Lambda policy. We give it the required. And the cool thing about this is that we now have then TypeScript support, and it should tell us that there are properties missing. For example, here it says now property version is missing in type. So we have a strongly typed object to define our Lambda policy, which is pretty nice. So because we want the Lambda function to be able to log to CloudWatch, we give it the right to create log groups, log streams, and put log events. That is at least what I think is necessary to do what we want. And then here I put the link where I found this. We want to send emails using simple email service, so we give it the rights to do so as well. Then we create the actual policy based on this policy document using aws.im.policy, give it a name, description, the path, and the actual policy object. So then, after the policy has been created, we attach the policy to the role. So the role then is allowed to do all those things. Okay, that's the policy attachment. And as you see, we don't need anything of its output, so we just don't put it in a variable. Okay, so this is our event handler, our Lambda function. There are different ways of defining a Lambda callback. In this case, I chose the aws.lambda.callbackFunction method. Define the text, memory size, the role, which we just defined, and the callback, which I set to the contactHandlerFactory, which we go into more detail very soonish, and pass the contactHandlerFactory the origin property, which we get either from the local origin domain configuration, so we can override it here, but as we don't do, we get it actually from the infrastructure origin domain. And here we have to resolve it to a string, and I couldn't find a better way of doing it so far, so if anyone knows a better way of doing this, please let me know in the comments, as I'm still not too proficient in TypeScript. So the only thing how I could get it working is like set it to unknown first and then as a string to tell, because the contactHandlerFactory, the origin, of course, expects a string. And this was the only way for me for now to make it work. And the same for contact email. So we can override it in the local configuration, but we don't have to. And if we don't, we get it from the infrastructure, which we do here. So the Lambda callback is defined, well, the Lambda function, but it has no endpoint so far. That's where we go now. And here you might notice the X. Before we just used the AWS module. And to show you on the top, we have AWS from Pulumi AWS, and then there's always also Pulumi AWS X. And the X stands for Crosswalk for AWS. And Crosswalk is essentially a helper around the AWS package when we go to the API gateway. So this is all everything needed to create our API gateway, our routes, and this will also create the edge optimized endpoint. So it creates a CloudFront deployment as well. And you could do this without Crosswalk, so without the AWS X module, but then your code would be like 5 times as long or more than this. As we are fine with the stuff AWS X is doing, we just use it as is. But we can check out the modules itself and do it manually if we need more control. If you, for example, want to create our own CloudFront deployment and don't use the Crosswalk the AWS sets it up, then we can do everything manually with the help of Pulumi, of course. So we set the stage name to be our environment, stage arcs, there we can define our tags, and then the routes, because and that's the reason why we actually defined the event handler beforehand and put it in a variable, because we want it on the same path, but for 2 different methods, options and post, and then we set the event handler. We could, of course, use this, I believe, any like this method, but I prefer to do it this way. It's not that much more code, and we can narrow it down and essentially block any other stuff we don't use, so nothing else kind of can hit our API. And I prefer it like this to be explicit. Next, our API gateway would give us an AWS domain, of course, but we have set up our own contact API, so we want to have our API gateway or our custom domain for the API gateway. So we use AWS in this case. It's not the AWS X, but the AWS.API gateway.domain name. Give it a descriptive name for Pulumi. And here, this is where our issued promise will resolve and will tell Pulumi, okay, this web domain depends on the SSL certificate to be issued already, to be verified. And here we get the certificate ARN, which is the Amazon resource number, I believe, something like this. It's like an internal ID of Amazon, for AWS. And we put it in here so Pulumi knows, okay, this depends on the certificate and gets its ID. So this domain can then use the certificate we created earlier to use HTTPS essentially. And then we tell Pulumi or AWS which domain we want to use for the custom domain. And our tags again. And as you see, we need the web domain, so we put it in its own variable. The next thing is a base path mapping, which essentially we could, for example, have the same web domain for different API gateways, endpoints, and then we could, for example, have a base path of contact. But as we don't want this, or I don't want this in this case, I prefer to have just a domain like this, because I have already the resource here, the path essentially. I set the base path to root. Give it the REST API. REST API. API is the API gateway which we created. And get the REST API from once it's resolved. So there it knows, Pulumi knows as well, that the space path mapping depends on the API being deployed already. Give it a stage name of an env of environment, domain name, which is this one. Then DNS records again. Finally create an A record for our domain that directs to our custom domain, so that our API gateway is allowed to use our domain as its custom domain. We give it a domain name from the web domain resource, type of A, the zone ID of our contact API we defined above, and then aliases, which is the CloudFront domain name, target health. That's basically CloudFront requirements. And here, the last thing, because this one itself is not using the SSL certificate, but as I learned from the Pulumi documentation, it still depends on the SSL certificate being issued. So we can say in the additional arguments, we can define that it depends on the SSL cert validation issued resource, which is this one. So only once this has been deployed, and let's go back, and of course the DNS Zone web domain, this is already handled by Pulumi, only then will this DNS record be deployed for the planning. Okay, that's the infrastructure part. Now let's go to the contactHandlerFactory, and then I can explain you a little bit more why it's a factory and not just a contact handler. So let's go to the top. Here's a lot more going on because it's our actual code. So yeah, we import all the required stuff. We will see later what we import and why and what we are using. A little helper is test. We get from the environment, and that's the reason why. Let's go back for a second. In package.json, we set our helpers like this, so we can know where we are, what we are running, where are we contact. But in this case, it's defined by AVA actually, and you will see later why we want this. Export const strings. This is essentially our localized strings for the email subject we want to use. In this case, if the email, so the website I'm using this on has an English and a German version, as you can see here, ENDE. And depending on which page the user is, the form will send the language along the contact form details. So then I can get, depending on this, the subject of contact request or the subject of in German Kontaktanfrage, which allows me to distinguish contact requests, the language it will be in, most likely from the subject. That's just personal preference. You can of course hardcode this, extend it. Here we set ourselves some TypeScript type shortcuts: API gateway proxy event, gateway proxy result, and the SES send email request, to shorten them up a little bit. Here we now define our actual contact handler, and we set our actual contact handler, and note that it's not the contact handler factory, which comes later, and you will see why. It's just to make it a little bit easier, not too deeply nested. And the contact handler receives a contact email, where then SES will send the actual email to, and it is of type contact handler config, which we get from our types, where we get body type as well. This is an asynchronous function, which then, okay, so actually this is already factory-ish style. This is a synchronous function which returns an asynchronous function, which then finally receives the event from Lambda, from AWS, of type API gateway proxy event, which returns a promise and a proxy result. In here, we try to do this line, which essentially goes from right to left, parse and sanitize our request, given the provided event. If this resolves correctly, will then be provided to the send function as body object, and to the send function, we also provide the contact email, so the send function knows where to send the actual email. We await the result, and if it succeeds, we don't really need the result, we just want to know if it succeeds. Then we have a little response, make response helper, to send a response of 200, which means successful, and just OK in the body. And if not, we catch, of course, the error. And here's where we want to, that's one place where I want to test, where I want to know if it's test, because in the test phase, like when I watch AVA testing continuously, I don't want to log all the console log errors, because AVA is already showing me enough stuff which is going on. So I don't want this. But if it's not in a test case, I want to see the error in CloudWatch actually, and that's why I conditionally log those errors. And if it fails, we don't want it to crash, but we want to make another response with either from the error provided status code or a status code of 500 and the actual error message. But we don't want the stack trace or whatever, we just want the basic stuff. And we will see later which errors it should throw and see why this should be sufficient. So then the client can decide what it shows the user, how it proceeds. So as I said, actually the parse and sanitize request is the first thing going on in here. So this is where it's defined, it's been defined. And parse and sanitize request is getting the event and it's returning a body. So in this time, let's go into the types below, down here. And the body will be an object or a rect containing an email subject of string, like all of strings, message, and the language, so we can change the subject. And here we have some more types, which are defined in this file because we use them all over the place. Okay, so let's go back to contact. In parse and sanitize request, we first body parse the event. We have here a lot more going on in lib library. Let's check out bodyParse. And what bodyParse is doing, it's taking an event, API gateway request, getting the content type, and if the content type is of type application JSON, then we JSON parse either, because Lambda, and I couldn't actually figure out Lambda, or better to say API gateway is sometimes base64 encoding the request and sometimes not, and I couldn't really figure out when. The only stuff I could find is when you define your response from the Lambda back to the client as base64 encoded or not. And usually you don't encode it only if you want to return binary files, I believe. And that's when you define your request as base64 encoded. But my test requests actually were always base64 encoded. I'm not sure why, but I just, to have both possibilities, check if the event is base64 encoded. If so, then we get the buffer from it, from the base64 string, from the event body. Or if this fails for whatever reason, an empty string, so this won't error, tell it it's an base64 encoded string, and then transform it to an UTF-8 string. So then we have a string in here, which is the JSON string, which we then JSON parse to get an actual JSON object. And if it's not base64 encoded, we just get the event body, because it's already should already be a JSON parse string, or JSON parsable string. And if not, if it's null or undefined, that's the newish, nullish coalescing operator from ECMAScript. If that's not available, then we provide an JSON parsable string. And I show you later why I did it like this. Because if you prefer, we could fail here too and tell our client, hey, this body is not valid or whatever. And if the content type is of type application x-www-form-urlencoded, then we behave a little bit differently. Do essentially almost the same thing here to get the body, only put in a body variable this time of type string, and then encode the body using the query string library from Node.js itself to parse the body. And I had to use the KV helper type. I don't know. I'm not sure exactly why or how, if there's a better way or if that's the proper way. And then had to return the encoded body and had to typecast it as body, as you can see. By the way, Pulumi works perfectly fine without TypeScript as well. You can use pure JavaScript if you prefer to. But I really like the, in my opinion, better IntelliSense and autocomplete stuff going on in TypeScript. So I prefer to end the errors, of course, to prefer to take on the burden and learn TypeScript on the go. So now we have if content type application JSON, if content type application, blah, blah, blah. Then if none of this is true, then we throw an error using our error helper of unsupported content type with a status code of 400. And a small explanation why I accept both content types, because for convenience, of course, from our JavaScript client, we would just use JSON, for example, to use window.fetch on our client to send the request. But if for whatever reason JavaScript is disabled, isn't enabled, isn't working, whatever, hasn't loaded properly, the HTML form would naturally send itself, if set up correctly, using this content type. So then this Lambda or this bodyParse function can accept both, like the JavaScript powered contact form request, or the HTML, the basic HTML JavaScript less request. That's the reason. And that's the reason why we have this helper, to be able to extend it, have more content types, less, and it's just cleaner to not stuff all in the same function essentially. So that's what's going on in this body parse. So that's the first thing. The parse and sanitize request gets the event, puts it in body parse, and whatever comes out there, if it throws an error, then this will fail, will catch and tell our client, okay, I failed. And if it failed in body parse, our client will receive unsupported content type. So then, if it hasn't failed, we go to the next part and put the result of body parse into the sanitize function, which Command E on Mac, Command G to search, is defined here, down here, so it's not too far away. Sanitize. Sanitize, in this case, is in the same file, could of course be in another file as well. We get the language, and I did it like this to make sure it's always at least in English, because it's not too important to have the correct one. But if it's able to get a correct one, then I rather have the correct one. If not, then I prefer to fall back to English and not throw. It's not that important actually to have a different subject line. In this case, if your case requires otherwise, then of course you can throw if no language is defined. So I put it in a string, like string interpolation, using the backtricks, I forgot the name, to make sure it's a string before I run trim, because I don't want to fail. Then I run trim if there's any excess white space going on before or after or whatever, string trim. And if this is empty, then I return en for English. So there we have our language. Because we need the language multiple times, we define it before. We return from the sanitize function, as you can see, another body. So we get a body and return a body. Just in this case, it's a sanitized body, and this is the unsanitized dirty body. We return email, which is body email. And we do the same stuff, because this is just sanitizing. This is not actually validating anything. It's just cleaning the input. So if body email would be completely empty after trimming, we return an empty string. Same for body message. In this case, we sanitize the HTML properly using sanitizeHtml, which is another helper, which we can go quickly in. It's not doing a lot. It's just actually using sanitizeHtml npm package, which seems to be pretty good at its job, ensuring that no one messes with our email, adds like iframes and images and stuff we really don't want. But we do allow a little bit, and that's what the helper is essentially doing. So we could use just the sanitize HTML defaults or like basic settings and stuff it in there. But because we do quite a lot of transformation beforehand and then setting the sanitize HTML library, I prefer to do this in this helper script. So to explain what we are doing here. So first, as some people still use this combination of the less than and sign and this 3 to essentially have an heart emoji like ASCII emoji in emails, and we receive some of them. And what I found in the beginning, that which explained here, preserve this ASCII emoji, otherwise everything after will be stripped. What we found in the early days of our contact form, where I didn't do stuff like this, when people would, within their email, so not always it's at the very end, but sometimes within or in the beginning, then everything else would be just stripped away, just dropped, so the message is gone. And not only do we want to preserve the heart, but we also want to preserve, of course, more importantly, the message probably following the heart. We replace it by an actual heart UTF character. And this way, we not only get a beautiful heart, but we preserve our message. So that's the first thing. And in this case, you can see I shamelessly mutate the string argument, the string received, which is not actually, if you know the basics of JavaScript, not actually changing the outer string. So it's not really mutating. So if you don't change a property of an object, or if you change a string coming in, you don't change the outside world. But if you change a property on an object, then you change the outside world. That's for another topic, and many people have already explained this much better. But in this case, as far as I know, this is totally fine to do. So we receive a string of type string and return a string. So we mutate the string, replace the hard as explained. Then we want to turn line breaks into HTML breaks. Doesn't matter how many of them. But then we want to compress multiple spaces to 1. So we don't allow more than one space, how many people will add there. Then we mutate the string again and use autolinker, awesome npm package autolinker, check it out, to automatically link non-linked, which can't be linked because our contact form doesn't allow HTML, or actually it doesn't care, but it's not providing ways for people to easily edit. So we never had HTML links in there, but we want to allow HTML links. But the next step is showing that we have some limitations. So then when we receive the email from our contact form via SES, we have easily clickable links. We don't want plain strings which we have to copy, paste, whatever. That's just annoying. That doesn't make sense. And usually Gmail, for example, should automatically do it, and probably most, but just in case, we do it ourselves. And the nice truncate option of autolinker makes it more readable and breaks it after 60 characters. That's just how I prefer it. We use the smart option location, which is truncating as a smart location, or at a location which autolinker considers smart. You have to check out the documentation for the differences. We're not going into this here. And then we're actually sanitizing the string using the sanitizeHtml library, which is this one. And then we define some settings. We want to allow the break, the B for bold, I for italic, EM for emphasize, strong, A, because we essentially just made our own links, if there are any, and iframes. I'm not exactly sure why. Yeah. So people could, which we never received, but could use or send us embedded YouTube iframes, and we allowed iframe host names. We set it to only allow YouTube. So in this case, they really can't send us other iframes than YouTube iframes. And allowed attributes we have to define additionally, because we only want to allow attributes on the href for the link, and on the iframe, the source, of course. So the YouTube iframes can even work. And non-text tags, I forgot what this is. No script, text area. Okay, I forgot actually what it's doing, but I'm pretty sure it's a smart decision. So according to this, in the sanitizeHtml package readme, discarding the entire contents of a disallowed tag. The exceptions are style, script, text area, option. Normally, with a few exceptions, if a tag is not allowed, all of the text within it is preserved, and so are any allowed text within it. We don't want that. We don't want any content of style, script, text area, no script. I don't know. At this point in time, it just felt right to do so. You can of course use your own sanitizeHtml settings, but make sure you use some sanitization settings and don't be too open. Disallowed tags mode is doing escape. We escape disallowed tags, so they're not discarded. As I said, that's personal preference, and as sanitizeHtml, I strongly believe is not trimming the actual text, because whitespace is not doing any harm HTML wise. We trim the string to remove prefixed whitespace and suffixed whitespace. So leading and trailing whitespace will be stripped, and we get a string of just like this, but it can have, of course, its whitespace in between. And then we'll finally return the string. Okay, let's set this back again and go back to contact and go back to where this is, sanitizeHtml. Okay, so then if body message is defined, we sanitize it, make sure it's a string. If not, we return an empty string. We return the language, which we kind of sanitized before, and then we return the subject if body subject is provided, which we are doing because we can make our contact form so that the form from the client defines its own subject. If it doesn't, which in our case it's doing right now, but I'm planning on another project where I want to use almost the same logic, or probably the same in the contact form example at least. There I want to define the subject from the client. For example, when you have a contact form where you can, like a select input field, define a subject, support, or for example sales, question, whatever, and then it can go to the proper department. In this case, we are not really changing the logic where it sends to. We can do this, of course, as well. In this case, we just want to have it in the inbox differently labeled based on the subject, essentially. So the subject, we use the sanitizeHtml as well. If it's not defined, so if this essentially returns an empty string, no, that's not true. If this is empty, then we use from our earlier defined strings, passing the language, or using the language index of the strings object, and get the subject string, which falls back to English. Maybe this is not the best logic, but we can improve it later. Okay, sanitize. let's go back where we came from, sanitize. So after we have hopefully successfully sanitized, which is always successfully because it doesn't throw, then we validate. Let's check where validate is coming from. It's here. It's a pretty short function, taking in a body, returning a body, and checking the message on getting the body object, and checking email getting the body object. And those are pretty simple functions defined here, which, if the body is not defined at all, just throws missing message, status or error code 400, returning the body object as well, so we can then inspect it later in our logging. And the same, similar as check email, but this is not only checking if it's defined or not, but if it's an actual email, which I can show you is from validator lib as email. So this is an npm package, validator, which I use in all my email validation essentially. I usually don't use other validators from it, but this email is pretty good, I like it, so I use it. So here, we not only check if it's an actual email based on the validator package, but so if this is not an actual email, it throws invalid email. Or if email block list includes the email, then it throws as well. And email block list is imported from here, from the root. We can go there by hitting Option or Alt on Mac, maybe Alt on Windows, I don't know. Is an array containing emails I want to be blocked. For now, I just, on the backend at least, I just do the manual and then every now and then redeploy the contact form essentially when I have extended it, and then I see how it goes. At the moment we receive like 2 or 3 spam mails per day, I believe. It's okay-ish. The plan is to, in the beginning at least, manually copy the spam emails, add them here, and check how often. So the plan is that when I add here an email, that I then say, okay, occurrence is 1, and if I see that an email is already there, I set this to 2 to get an idea how often the same email address is spamming us essentially. That's just how I get started with it. On the front end, on the client, I might add a small math capture to try to prevent like the simplest stuff and see if it helps, and then I will see how I continue. But I really want to avoid the reCAPTCHA stuff or similar external services, because I want to minimize the privacy policy requirements for GDPR, especially because we are from Germany. So a lot of our readers, most of our readers, I believe, are from Germany. So we have to adhere to the GDPR, and I want to avoid any unnecessary service. So I don't have to show, if possible, a cookie banner or whatever. And for this reason as well, avoid the reCAPTCHA. Even though, of course, the invisible reCAPTCHA is a pretty cool idea and pretty cool service. So that's what's happening here. If one of those is essentially true, so if it's not an email, or if the blacklist includes the email, then it throws invalid email. Let's go back, Command E, Command G. And if none of those fails, so if one of those throws an error, then it won't return, of course. And if it throws, we go here, then the parse and sanitize essentially throws, which is in here, which make this try block fail, and the catch block then responds with our error message we defined earlier. So that's what's happening, parse and SanitizeRequest. So then, as we saw, our validate, which hopefully didn't throw, returns our parse and SanitizeRequest, returns the valid body now. It returns a body. So we can stuff it in body on the send argument object along the contact email. Then we can come to the send function. Send function, we define the send config helper to declare what we require and return a send config as well. No, we don't return. This is bollocks. It doesn't return anything. What does it do? It returns a promise, of course. And in here is the more important part why we have defined the test helper. If we are in a test environment, which, as said earlier, we get from the process environment env node env test, which is set by AVA automatically. So if we run AVA, then isTest will be true. So we don't send an email, because I don't want to send an email on every test run, of course, only in Lambda world. Another option might be to check if this is a Lambda, or like if this is in a Lambda context, running in a Lambda context, and only then send an actual email. For now, this is sufficient for me, so I go this way. So if this is not isTest, so if this is not a test environment, we return the promise from new SES V2. This one is coming from AWS SDK, the official SDK, JavaScript SDK from AWS, and we destructure the SES V2. There's also just SES, which is then essentially the first version, and I forgot actually the difference between those, but I just use it, and it works. That's the most important part. We have to define the API version, which of this time is this one. Then we send our email with another helper, which I explain why. We could have put, as you can see, as request is here, we could have stuffed all this configuration in here directly. But then we couldn't, for example, test as request. And I think it's why not. We split it apart, make this one shorter, more readable, have this one separate, minding its own business and returning the necessary EQ, which we defined here somewhere. SES send email request. So which is the required property of the send email method. And we don't define the optional callback because we go with the promise method instead, which we return to in the send function. And when we go back send here, then you can see we will return the promise, so we can await it here. And then we can fail and do all the handling in here. That's what I like. So that's the send logic. And in the as request, we receive the whole body and the contact email as send config type. And then, as per SES documentation, set the from email address, which will be the body email. So our contact form, actually that's wrong. So our from email address should be contact email. What we want is our email to be sent from, or to be coming from, our own email address, because we can't send as another person, we don't are, and we can't verify the email, of course. And we want to send this email to ourselves using our own email address, but we want to be able to reply to the person, so we use the reply to addresses in this case, and set just one, the email of the actual person sending us an email using the contact form. So in this case, we receive the email from ourselves, from our own endpoint essentially, and still be able to hit the reply button using the reply to address and setting it to the actual sender of the email. And then the content, and this is at least one part of where SES version 1 and 2, or SES and SES V2 differ. This object is defined differently. So make sure you use the right AWS module and define the correct configuration object. So the body of type HTML, charset UTF-8, data body message. And if in this case it's actually not too useful, probably because we can receive HTML, we are fine having HTML and we want HTML. But at that time I thought, or maybe I knew, it's better to also include a text-only email where we strip the HTML. Let's check what it is. Strip HTML. We have another helper, strip HTML, which is using sanitizeHtml as well, just with other options, replacing the HTML line break with an textual line break, and this allowing any tags and any attributes. So it's like stripping everything away, but preserving line breaks using the ASCII line breaks. Strip HTML. And next we set the subject of our email to be body subject, which we have sanitized, validated, and should be either coming from the contact form or from our strings earlier. So this should be almost everything of it. And now we come to the actual exporting and of the contactHandlerFactory, which received the origin. Remember, let's go contactHandlerFactory. It receives the origin and it receives the contact email. We give it a origin, and because the rest we don't care in here, we just spread it or rest it in config and pass it to the contact handler. The origin, because we have some middlewares, and I've just preferred to set it up like this, using a pipe helper function to have the course endpoint and normalize Lambda event. That's just a small little helper to right now only lowercase essentially the headers. Because I realized that the headers have different casing and I really don't want to care or have to deal with those different casings and rather receive all headers in lowercase. So I have this middleware which takes a handler and returns another handler, basically, the proxy result. Yeah. And which just normalizes the headers for now. If we want to normalize other stuff on the Lambda event, we can do this in here too. And the normalize headers is just a small function I found on Stack Overflow, was too lazy to write it myself, using a for in loop and lowercasing the key and the value essentially. That's what we're doing. And course is another function defined in here in our library, which is inspired from Express.js course implementation. I tried to read as much as possible about course. It's kind of a little bit confusing, kind of simplish, and but yeah, for example here, always set a very header, That was a good find on the ROS cores package and the core.js package. And yeah, we have some functions which check if the origin is allowed. And then we configure the allowed methods and stuff, configure the headers allowed. And this is the actual middleware receiving the course options, which we set here, which is right now we care only about the origin we want to allow, which we receive from our Pulumi infrastructure code. So once it received the options, it returns a function which takes in a handler, which then returns an asynchronous handler itself, which receives an event. So this way we can chain all those middlewares to finally receive our event handler or contact handler in this case, and like really do our actual business logic, which is in contactTS. So we get the origin from the event headers origin. We check using the isOriginAllowed function, handing it the event, the origin, and the options allow origin to see if it's allowed. And the options of the course middleware, the allow origin option of the course middleware can be defined as an array. So if it's an array, then we loop through it and check if any one of those is allowed. And so it's like a recursive call. It calls itself, checks if the string is allowed. If it is allowed, it just returns true and stops the loop and further processing. If this won't return nowhere, if none is allowed, it returns false, of course. So then none of the allow origin array elements allows this specific event origin. But if it's not an array, a function instead, we call this allow origin function, providing the origin and the event. So then we can, in the options, define more logic how we want to allow this. Or if it's a string, we just check origin against allow origin if it's and return the result. And if it's of instance regular expression, then we test the origin against the allow origin, or the allow origin, we test it against the origin, return the result. If none of this is true, then we just return false. So then we come back here. So this allowed is then either true or false. Then we define the headers, spreading in some default headers, which are content type, application.json. This is what we always return at the moment, and as found in other implementations, the very origin header. Then we set the access control allow origin header, which is almost the most important one. If it's allowed, we essentially return the request origin, because we figured it's already allowed based on our own logic. If it's not allowed, we set it to false. I'm not exactly sure why set this to false, but this is what I found in most implementations, so I just followed their example, and it seems to work for me, at least, which is beginning. Then we set the access control allow methods to say which methods we allow. Configure methods, let's check it out. We allow essentially all those, which we could, in this contact form example, narrow down. So we could, even better, options allow methods go here, and then with course, say here, allow methods, say we allow options, where is it? And post. Because that's all we allow, actually. So then, methods have been configured. Then we configure the headers, which are those content type, accept, referrer, user agent, and DNT, which is do not track, which we allow, but which we don't do anything right now because we don't track in this specific case of the contact request. We don't do anything. But if we would start to do any tracking and we want to be nice, we can then see if the DNT, the do not track header, is supplied and follow it accordingly. So then we have predefined this headers object. Then, if the HTTP method is options, which we have just allowed here, it's options, then we return, is base64 encoded as false, we return our headers, those, plus a contact length of 0, which I found somewhere. I forgot to add the source. It might be in here, in one of those, or even Express, I'm not sure. But there they, oh no, this. They said that some browsers of Safari, I believe, fails if the body is empty, like this, or the options result is empty and the content length header is not set to 0. I don't know, I just did it to make sure because it is 0, we set it to 0, and why not define it? And then I had used the 204 status code and change it back according to this linked comment from Lukas Kalbertot. I hope that's pronounced correctly. Yeah, according to his comment, it makes 204 would make sense, because 204 essentially is successful response containing nobody. But he explains that it's still better to use the most widely spread success status code, which is 200. So I just follow this, because it's kind of hard to know exactly all details at times, and just follow some best practices you think are good best practices. So, and if this wasn't an options method request, and if we haven't returned here, then we come to the actual response, to the actual handler. Then we invoke our handler, which, remember, handler, we received from the CORS middleware here. Because this CORS middleware, or all those middlewares, essentially receive the contact handler. And then, down here, it'll await the result. Because we could just, in most middlewares, we could just return the handler and be done with it, and we don't have to await it. But because we want to change the response as well, because we want to make sure that the CORS headers we already have defined in here, and we don't want to mess around later on, but we want to make sure the response contains the CORS headers, we await the handler here. So this handler not only handles the input, but also the output, so it kind of really wraps the original handler. Other middleware, for example, just prepend itself to the handler, do some stuff beforehand, and then just hand the work over to the actual handler. But in this case, we want to change the response, which we do by awaiting the response, modifying its headers, spreading our own headers in, and merging it with the response headers. And we do it in this order, spreading the CORS headers first. So we could change the response headers or override the CORS headers from the handler response, which might not be the best actually. It might be better to do it like this to ensure they are always consistent. But for now it worked for me. I stay with this. If you know anything better, you can of course write it in the comments and let me know. I'm always open to learn new things and improve my code. That's why we're all here, right? So let's go back. We have finished the CORS handler. Normalized Lambda event we already did. So those will be piped together to form a new function which receives essentially the same inputs as those do receive. So this one will be a combination of those. And the middlewares then will receive the actual contact handler, which receives the config, which then make up the contact handler factory, which we define in our callback function, stuff it in the callback property, callback and contact handler factory, and give it its required options. That's actually what's happening here. Yeah. And then I have some more middleware, at least this block bots, which I don't use right now, but we can use it to block bots, essentially according to some list. In this case, I used the isbot npm module, but again, I'm not using it actually right now, because if I want to use it, I would stuff it in here. And note, the normalized Lambda event is running first, so it's going bottom to top. So it's first normalizing the Lambda event. The CORS handler receives the normalized Lambda event, so it can check for, in the CORS, for example, for event headers origin, and it doesn't have to care for the casing. So it doesn't have to check for origin, and then, for example, event headers origin to make sure whatever the casing is. And actually, I couldn't find so far a proper explanation on how the casing of the request headers will be. Okay, so now that we have gone through all the essential code actually, contact handler as defined, as explained, defined, and infrastructure, let's actually deploy our contact service. So for this, we have our helper as well, yarn, deploy development. We run it. It will ask us for our passphrase, we provide it. And then it'll plan the deployment of our contact dev service. So here you can see that it read the Pulumi. Oh, we run into an error. Running program. What happened? So here we run into an error in the planning phase. So nothing really happened, but I could already figure out that some error occurred. Maybe reading the infrastructure. I don't know why, but it should, at least shortly, fail, as it just did, and show us kind of required output DNS does not exist on stack infra dev. Why does it not exist? Let's check out. So close it, infra dev, config. No, this should be in here. That's probably because we don't export it. Why don't we do this? Why has it worked for me before? Maybe I cleaned some stuff up and wasn't. That should actually be it. Let's try again. Okay. Clean up. Passphrase. Let's see. So it's reading the pulumi.StackReference in. And it's erroring again. Maybe we forgot more dependencies to export. Why though? Tell us, please. What's the issue this time? Huh? Doesn't even say for diff. Is it not able to Pulumi stack list? That's odd. Let's go back to infra, and we can just deploy it again. Passphrase, and see what it exports. If it exports the DNS zone. Sorry, the passphrase. Previewing the update. There, it should figure out that there's no update to make. Please forgive my slow internet connection. Zone ID, update. Ah, yeah, okay. That's an interesting thing. We now exported, we set this to export the DNS zone, and the file exports it. But our stack hasn't actually exported it before. So it's stored in the stack, in the internal stack references, essentially. So it asks us if we want to do this update. And in this case, update just refers to the updates to the output. So it's not actually doing anything on AWS this time, but it's still changing its internal references, its internal state. So when we now hit yes to actually perform this update, it should be quite fastish because there's nothing else to do, even though my internet connection is really slowish. You see, and as you can see now, the diff includes the DNS zone, which it didn't before. So I have no idea why I forgot it and why. Whatever. Now, if we go back to Pulumi AWS contact, and here the yarn deploy development and provide our passphrase. Now it should work. It should. Fingers crossed. Reading in the stack reference here. Hasn't errored yet. That looks good. At least no, not the type of error we had before. Now it's creating. And you see this time we have a lot more resources because of all the certificate manager stuff, all the certificates, all the more DNS records, API gateway, domain names, path mappings, stuff going on, permissions, and so on and so forth. There's a lot more going on. And as well, the certificate, as I explained somewhere before, the certificate validation takes a little bit. That's why we needed the additional helper from, where is it? That's not an infra, it's in here. The additional helper from Pulumi. This one, that it's issued, certificate validation. And this takes a second. So when we check here, the certificate validation, that's not the issued part. So this one is actual validation that's creating. It takes some moment. And those things are all created. So now we only wait. Oh, the validation has succeeded. The namespace records have succeeded. Now we're waiting for the asynchronous actual issuance response. And this can take a few seconds at the first run. So when you change anything on your code, on your infrastructure code, or on the Lambda code, which then would change your infrastructure code as well, of course, and you redeploy, but you don't change the whole thing or change logic on the certificate stuff or whatever, or the domain, then it doesn't have to revalidate the certificate, because the certificate doesn't have to be reissued. So then only the parts you changed, I can show you this when this is done quickly. Then you only really like update the difference, and probably that's what you most likely are going to change is the Lambda function itself. Then only the Lambda function and maybe some related internalish stuff will be updated. So this will be much quicker, and the certificate validation doesn't have to be awaited. And I really, really highly, highly recommend infrastructure as code when you want to do cloud stuff, when you want to go into AWS or Google Cloud or Azure or whatever. It's just too much stuff going on to really, like, the only other option would be either you have like really, really just one resource, for example, like just DynamoDB, for example. Then it is possible, and especially just one DynamoDB in one region. Or you manage the stack, which Pulumi now manages for you. You manage it in a spreadsheet essentially, and you have to note on what pages, which settings you made in which regions, because it depends on the region, it depends on the service, like on the AWS service, and there's so many connected things. Like the CloudWatch, we're kind of not really doing ourselves here, but is also going on behind the scenes, so we can have the logging and stuff. And to really have an overview, kind of you have to use infrastructure as code. It of course doesn't have to be Pulumi, but I really like that it's just code, that it's TypeScript, that it's typed. And the cool thing about Pulumi is that it actually can reuse the logic of Terraform. So it at least supports, or it should at least support, the same as Terraform, and can provide more, of course, but it can just ingest the Terraform logic. I don't know exactly the logic behind the scenes, and I don't know a lot about Terraform, but it essentially can just use the Terraform providers or whatever to do its thing. So that's pretty cool. So as you see, it's still waiting for the certificate to be. We can go to the AWS console. Where are we? Management console, and we can check out ICM Certificate Manager. It's still issuing, or still waiting for the validation. And we should be able to see our contact API domain.com pending validation. And we can check, make sure that this thing here has actually be Route 53. Let's open this in a new tab. Has actually be set on our zone. There is CNAME, low-48AB, blah blah, low-6FE. That's it. So it has the proper record. We can check here ourselves. Still pending validation. Oh, it can take some time, so I'm probably cutting at least parts of it to not bore you. But yeah, in this case, it's not, or at least not only because of my slow internet connection, but because of DNS validation. By the way, one of my favorite emojis is this one, actually, the shrug emoji, the tables. Okay, so essentially what's taking so long here, I think, even though we have the Route 53 records correctly, is that I forgot that in Route 53, our domain, api.domain.com, does actually not exist. It's not a valid domain. So probably, or at least I don't own it. I haven't set any NameServer records, so it can't validate anything, can it? Has it validated anything for? I don't think so. Has it validated those? I'm not sure. But this is a little bit suspicious, and it's probably-ish what the reason is why this is taking forever. So we proceed by Control-C'ing this, terminating. And Pulumi is telling us, note that terminating immediately may lead to orphans, resources, and other inconsistencies. So then we can make use, where are we? In the context of our yarn stick export. So if all the domains and stuff are valid or existing, this shouldn't be an issue, of course. But we can use this opportunity to see this, to see how issued, how we can manage those cases. No, so it's kind of a good thing that it happened. Pending operations. No, so this Pulumi export, as you can see, is a huge JSON file. Deployment. Those are the resources, and below are the pending operations. So I believe that if we just empty this array, this is just the issued resource. So everything else will be fine. It's just not getting the information back that it has been issued. We save it. We just empty this array. We save the file. Now we do the import command, which in turn just runs Pulumi stack import file Pulumi export, as defined in the package.json. And it'll tell us if this is okay, at least, if this file is valid. Import successful. And now we can deploy again and see what happens this time. Passphrase. Reading the stack reference. My fault. We have emptied this operation, and because we want index contact issued, but this issued, what depends on the issued? The web domain and the base path mapping. Now the A record. Okay, just for this example to deploy it, we will get rid of the issued resource and the domain stuff. So we don't have the custom domain, but this thing won't run anyway properly because the domain is not existing at all. So we just comment it out for now. Clear this, run it again. Now it shouldn't run into the forever running validation again, but it should properly update, because most of the stuff should already be there. We will see what happens now. You see, nothing has changed. We perform this update, which is actually pretty useless because it's not doing anything, but we just do it so we can see what happens, and then we are actually ready. So if you follow this, or if you clone the repositories and provide a proper domain you own, you have control control over the DNS settings, then this shouldn't be an issue, of course. And for me it worked. Let me know if you have any problems in whatever case, of course, in the comments or via Twitter. And just to make sure, let's make whatever stupid small change probably in the response contact handler. Let's say okay, yay. Now we want to return okay, yay. Now we deploy again, just to show you what happens when you make a change to your Lambda function without changing your actual Pulumi file, your infrastructure. Then it'll diff the changes, figure out what has changed and what hasn't, and should just work. Go to Lambda. If this works, because it's pretty bad, the connection, and the source window is not so responsive on my machine or in my internet connection here, 101, contact handler. Pulumi is appending this random ID to make sure you have always unique names, and it's keeping track, of course, of the names for you, so you don't have to deal with this stuff. That's another thing. Oh, that looks good. Goodish. Okay, yes. The planning phase is still going on. This stack reference reading, I don't know if it's my machine, it takes a little too long for my liking, but it's okay. It's much quicker than combining all in a monolithic stack, trying to combine everything. Oh, now it's doing it. There it says it's updating the Lambda function, the REST API, and replacing some deployments and permissions, and updating the stage. Let's do this. And here we could search for OK and see that it's the response. Now this is quite interesting. Now it says it has already only updated the function. That's a little bit confusing, but it's okay. For me, it has always worked pretty good. So now it should contain the OK. Yay. Yay. There it is. Updated. Quick and easy. All automated by Pulumi. Okay, so now that we have seen how to deploy and update our infrastructure, let's see how we can destroy it again and let Pulumi take care of removing all the resources on AWS we have created. For this, we can run... we could, of course, make ourselves a helper script as well. But in this case, it should be fine running just Pulumi destroy. And note we're doing it in the contact service to the passphrase to remove the contact service first. There it shows which resources it'll delete. We hit yes. Dum 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 dum. And in here, and then we can undo our changes. Looks good so far. Deleting the DNS record for the certificate. Certificates seem to be always the slowest. Name servers. So this, because of all the red color, looks kind of like it errored, but it didn't. It tells us 16 resources deleted. Yeah, and that's actually it. And it tells us the resources on the stack have been deleted, but the history and configuration still with the stack are still maintained. So we can just hit Pulumi up if we want to redeploy it, or if we really want to remove the stack, follow the instructions and Pulumi stack remove the contact dev stack. So now that the contact service has been destroyed, we can go back to functions and should see no function here. So let's head over to the Pulumi AWS infra and do the same. Destroy it. Yes, 8 resources to delete. Confirm. We can already reword our changes here, and we commented out the certificate stuff. I can undo this too and hit save. Done. Awesome. So all the resources should be gone when we go to Route 53, host zones, which were there before. So no domain.com resources left. Route 53, SES. Domains, no email identities, and API gateway. Those were the biggest resources used. No APIs. All good, all clean. Perfect. Thanks, Pulumi. That's it for the contact form service. Thanks for watching. Next up will be my first live-coded newsletter subscription microservice. So hit subscribe if you want to be notified. And let me know in the comments or via Twitter if you have any feedback. And see you hopefully soon. Bye.